Thermodynamics. Define enthalpy change of atomization of a compound. Enthalpy change of atomization of a compound is enthalpy change 1 mole of compound in standard state is converted to its gaseous atoms. Enthalpy change of atomization of element when 1 mole of gaseous atoms is formed from an element in its standard states. An example of atomization of a compound is this: NaCl solid arrow Nag plus Clg. Define first electron affinity and give an example of first electron affinity with oxygen. First electron affinity is the enthalpy change 1 mole of gaseous 1 minus ions is formed from 1 mole of gaseous atoms, and this is the equation for with oxygen: Og plus E minus to O minus G. Define second electron affinity and give an example of second electron affinity with oxygen. Second electron affinity, enthalpy change 1 mole of gaseous 2 minus ions formed from 1 mole of gaseous 1 minus ions, O minus plus E minus to O2 minus gaseous. Define enthalpy change of hydration. Enthalpy change of hydration is enthalpy change of 1 mole of aqueous ions is formed from 1 mole of gaseous ions, and here you go. Na plus gaseous arrow to Na plus aqueous. Define enthalpy change of solution. Enthalpy change 1 mole of a solute is dissolved in enough solvent so that no further enthalpy change occurs in further dilution. NaCl solid to NaCl aqueous. Define bond dissociation enthalpy. Enthalpy change when all the bonds of the same type in 1 mole of gaseous molecules are broken, Cl2 gases to 2Cl gases. Define lattice enthalpy of formation. Enthalpy change 1 mole of a solid ionic compound is formed from its gaseous ions under standard conditions, Na plus gases plus Cl minus gases to NaCl solid. So therefore lattice enthalpy of dissociation is 1 mole of a solid ionic compound is completely dissociated into its gaseous ions under standard conditions, NaCl solid, Na plus gases plus Cl minus gases. Lattice enthalpy is the measure of ionic bond strength, and the two types of lattice enthalpy: lattice enthalpy of formation, lattice enthalpy of dissociation. Two assumptions of pure ionic model of a lattice: assumes all ions are spherical and assumes the charges of ions are evenly distributed across them. How to work out theoretical lattice enthalpy? What happens if you find lattice enthalpy experimentally? Well, by doing calculations based on purely ionic model of a lattice. If you do it experimentally, the value you get is different, and therefore evidence most ionic compounds have covalent character. Why do most ionic compounds have covalent character? Well, the positive and negative ions in a lattice aren't exactly spherical. The positive ions polarize the neighboring negative ions to a different extent, therefore more polarization, and the more polarization, more covalent debonding. So 3 things that happen when a solid ionic lattice dissolves in water. Bonds between ions break to give free ions. Endothermic. Bonds between ions and water are made. Exothermic. Enthalpy change of solutions overall enthalpy and effect on enthalpy of these 2 things. Why can water molecules bond to the ions? Because oxygen is more electronegative than hydrogen, so it draws electrons to itself, creating a dipole. The dipole creating a dipole force, and the hydrogen atoms can bond with negative ions, and negative oxygen atoms bond with the positive ions. Why in general do soluble substances of exothermic enthalpy of solution? Substances generally only dissolve if energy released is same or greater than energy taken in. Define entropy S, and what does a high entropy mean? Entropy S is the measure of the number of ways particles can be arranged and the number of ways energy can be shared out between the particles, and high entropy means more disordered the particles. Why do substances tend to disorder and define feasible? Substances tend to disorder because they're more energetically stable when there's more disorder, therefore particles move to increase their entropy because they're more energetically stable when there's more disorder. Feasible means a reaction happens by themselves without addition of any energy, even when delta H is endothermic. Find standard entropy of a substance, and what does increase in total entropy mean? Standard entropy of a substance is the entropy of 1 mole of a substance under standard conditions, 100 kilopascals at 298 Kelvin. Increase in total entropy means it's feasible for a reaction to occur. What is free energy a measure of? What if delta G is negative equals 0? Free energy is a measure to predict whether a reaction is feasible. If delta G is negative / equals 0, a reaction might happen by itself. And these things are now really important. What is the reaction for delta H positive, delta S is positive? delta H is positive and delta S is positive, the reaction won't be feasible at some temperatures but will be feasible at high temperatures. And if delta H is negative and delta S is negative, the reaction is feasible at low temperatures but won't be feasible at higher temperatures. What happens if delta H is 0 and how to find temperature at which reaction becomes feasible? If delta H is 0, a reaction is just feasible, then how to find the temperature? Well, delta G is 0, therefore instead of delta G equals delta H minus T delta S, delta H equals T delta S. And that's when, if delta G is 0, reaction is just feasible.